For the IT example, we're going to use the Smart Outlier Detection Assistant to identify anomalously high web transactions leveraging the density function algorithm. So this data has already been pre-cleaned and aggregated for us. And what we see in these columns are the app servers. So we have app server 1, app server 2, app server 3, all the way through 11. And then the time. And so these are in 1-minute increments. How many transactions occurred on that server? So because this data has already been pre-chewed or pre-processed for us, all we have to simply do is select the field we want to analyze. So in this case, we want to look at app server 1, which is the column that has all the numerical data. And we're not going to do a split by. And the reason for that is there's no logical grouping in these servers, like a server type, they're all kind of the same. And so there's no reason for us to do a split by in this case. The distribution of type of auto, we're going to leave because we don't know what the distribution for app 1 is. And so we're going to let the algorithm figure it out. For the tolerance threshold, I've already put a custom parameter in here. And that's primarily because I want to look at global outliers. I don't want to see local outliers for this particular app server. And one thing to note is if you click the SPL button on the right, it will show you how to write this search if you want to create your own dashboard or run this search separately and play around with the parameters or try it out on new data. So when I click that Detect Outliers button, it's going to take all the data that's in column app 1 and start looking for the anomalies in there and creating a baseline. And so in this case, it's found 32 outliers, and those 32 outliers exist basically above 324. So within a 1-minute period, if I've had more than 324 transactions, that would be considered anomalous. And we can see actually on this graph that at one point there were 1,700 transactions, which would be, anomalous for a 1-minute period. When the bulk of our transactions are anywhere from 8 to 300. So that increase tells me that at some point something failed either in my IT infrastructure on the load balancer side, or there was some kind of issue where app server 1 was processing most of the transactions. And when I look at the model file, it gives us some additional information, like the distribution type is Gaussian KDE, and the mean number of transactions for this server is 76. So that gives me a pretty good idea about how many transactions should I expect to see on this server during a normal time period, a normal 1-minute time period. The other thing that this page will show me is if I go to the outlier analysis, this only works if I have a split by. So if if I had some additional labels in here, like the type of transaction that was occurring on the server, I might see that information here. But in this case, we don't have that logical split, so it's going to go ahead and just provide the aggregated number to the user. It's not going to provide any other type of outlier analysis because we don't have any other data point or field to key off of. And when I click Save Experiment, this will allow me to publish this model.